is William Walker. I'm Chief Technology Officer at Cullen Technology Corporation. During my time at the University of Houston, I was in the Material Science and Engineering program, and I graduated in December of 2016. I would say my fondest memories here at UH would have been the time that I spent with my co-students in Dr. Artabily's group. It takes a family when it comes to grad school. I would say UH has very high standards, from what maybe I've seen at other institutions when it comes to not just engineering, but engineering at the graduate level. My education here definitely prepared me for my career. So a little background on me, I focus on lithium-ion batteries and specifically thermal runaway and battery safety, and designing batteries that, should a thermal runaway event happen, it occurs in a safe way. The reality is thermal runaway is a very complex situation. I was fortunate and I had the benefit of studying that here at the University of Houston and doing research on that. And it was those practices and principles and things I did my research on here at the University of Houston that have really driven how now today at Cullen we tackle battery problems. A lot of what we do at Cullen is focused on solving problems related to thermal runaway. And for something so complex, the best way to tackle it is to really just get down to the fundamentals. For me, getting down to the fundamentals goes all the way back to what I was learning here. So every battery my team touches, we touch it with a safety first lens. There's no exceptions. There's nothing that's stripped out. If it comes out of my team, if it's one of our architectures, it will be a battery that is designed to fail safely, if you will, should a thermal runaway event happens. And so that's what we're doing now today at Cullen, is we're trying to flip the script a little bit on what does it actually take to have a military and defense or space grade battery that is safe. Does it really take a $10, $20, $30 million development program, or can we achieve that with a commercialized energy storage system? The latter is what we're working towards. My time at NASA, I'm very blessed to have had time at NASA. That's where I got some of my standard training from. Started off working in the passive thermal group where I was focused on studying the International Space Station and doing simulation of the heat transfer of the ISS as it orbits in and out of the sun. You imagine something that's going in and out of the sun every 45 minutes to an hour and a half, going at 17,500 miles an hour. Your components are going to get really hot and then really cold and then really hot, back and forth. And you have to design systems that can withstand that. That was going on in parallel to when I did the graduate program here at the University of Houston. And so I actually did not come to the University of Houston thinking, I'm going to be a battery person. I started the program and Dr. Artabily specialized in lithium-ion batteries. I had the thermal background from NASA, and so it was one of those, we're going to put two and two together and I'm going to focus on the thermal aspects of batteries. So breaking it down, we had a very simple problem statement. A lithium-ion cell will go into thermal runaway. Some of the heat will stay put, some of it will be ejected away. What we found was that there was no technique available in the market that could give us that measurement. So we gained funding. We developed a calorimetric technique that we refer to as the FTRC. That technique has since been patented, licensed, commercialized, and data from it has now been used to support space exploration, automotive, eVTOL sector, military and defense, you name it. We have a real opportunity to reduce risk in society. So there's a global push for circular electrification. What this means is there's going to be more and more and more batteries, whether it be more Teslas or more drones. We have more batteries in society. The reality with thermal runaway is that with sound engineering practices and good judgment up front, we can take the risk of thermal runaway, which can cause catastrophic damage. It can cause loss of life, loss of property, loss of time. The list goes on and on. With sound engineering practice from the beginning, we can wipe it right off the risk map to the point where you don't even have to think about it. This is one that's solvable. I think it's important that everyone knows that these battery fires don't have to happen if we use sound engineering judgment from the beginning, and if we encourage our pack developers, no matter the vertical, no matter what sector that it's coming from, to use sound engineering practice and build with a safety first lens. This is a solvable problem. I just think that's really cool. I'm deeply honored to receive this award recognition. The university puts out a lot of stellar students every year. I think back to even just in my graduate group alone and to the students I was surrounded with. It's humbling, I'm honored, and I'm frankly very excited.
Go Cougs!